just like to remind everyone that you're going to have your second exam next week. Okay, so I hope you didn't what we call forget it. So we will have our second exam next week, and unfortunately some students were affected with the college. I don't know if you are one of them. Okay, they started putting WA if you didn't fulfill the requirement for vaccination, I think. I just saw it as a message in my Blackboard this morning. That's why I just want to what we could remind everyone in case you're the one who is involved in it. So when I open the Blackboard, okay, so there's some sort of an announcement that the college has implemented, okay, those type of what we call rules. So if you're not, you didn't satisfy your thing, vaccination, you're going to what we call be given a grade automatically of WA. So to remove it, I think you have to do to what we call satisfy the requirement that they ask you to do. Okay, so the one that we have this week topic are not even included in the exam, but it doesn't mean that you're not going to what we call don't listen anymore to the lecture, because we may delay the exam just to give you time to prepare. Okay, but we continue on with our life on what we call doing the thing. So we have started with acids and bases last time. Okay, so we said everything around us can be made up of acids and bases. Acids are what we call they taste sour. Okay, well, base usually they taste bitter. Acid is the one that's contained in most of the fruits that we have. Okay. Now, acids usually reacts with certain metal to produce hydrogen gas. It reacts with carbonates and bicarbonates to produce carbon dioxide. If you have this so-called volcano eruption, where you have sodium carbonate reacting with acetic acid. So usually what you produce there, CO2 and water as one of the product. Okay. Now bases on the other hand, they feel slippery. They contain in mostly cleaning materials. And if you have too much of acids, you take antacids, which are usually basic. Okay. And when we discuss about the Bronsted acid definition, or the so-called Bronsted-Lowry acid definition as a proton donor, okay, and a Bronsted-Lowry base as what we call a proton acceptor. Okay, and here we could say water lose the hydrogen to ammonia, so your water is an acid, okay, and ammonia on the other hand accepted the hydrogen, so that's the base. So your acid here in the reactant side becomes a conjugate base here, and your base here, upon accepting the acid, becomes the conjugate acid of that what we call base. So we could say the Bronsted-Lowry definition of acids and base is just the one that has the conjugate acid-base pair. Okay, and then we also have some example like this one. So in this case, your HF is still the acid because it gives off hydrogen. It donates its hydrogen to ammonia, and ammonia is still what we call your base. And I think if I'm not mistaken, we end up on this part, okay? The acid-base property of water. So water has a unique property of being able to form an acid and a base, whether it is one water producing H plus and OH minus, or two waters wherein one of the water donates its hydrogen to another water, giving you hydronium ion, H3O plus, and the hydroxide ion. So here you could say that you have both what? The acid and the base. Okay, or water acting as an acid and a base at the same time. And out of this, we end up with an expression of a new K, which is the so-called Kw. Okay, so if we're going to look at the Kw here, the ion product is just the product of the molar concentrations of H plus and OH minus at a particular temperature. And usually it's given this value, 1.0 times 10 to the negative 10. And depending on the amount of hydroxide and hydrogen ion, it can tell you what solution do you have. If they're both equal, you have a neutral solution. If H plus is more than the hydroxide, it is acidic. If H plus is less than the concentration of the hydroxide, then it is what we call basic. Okay, and I think we did some calculations like this one. Where did we end? Did we do this, class? Hello.
Hello, can you hear me?
Yep.
You ended at 15.5.
We edited at.
15.5, example 15.5.
Oh, okay. So we already get what we got a long way. But the thing that you need to know is this relationship that we have, or the relationship of pH with respect to H plus. So what does it mean? Okay. I think if I'm not mistaken, we put it like a seesaw relationship between the two. If the pH is low, the hydrogen ion is high. Or if the pH is high, the hydrogen ion is low. Okay. So pH meter is the one that they use to measure the pH. And if we have pH equals to negative log of H plus, we also have this relationship. POH equals to negative log of the hydroxide ion. And if we're going to relate them with what we have earlier with the Kw, we end up with a relationship like this one, which is just pH plus POH will give you 14. So if we already have here, so let's try to solve this one. Did we solve this now? Did we solve this, anyone?
Yeah, we did.
Oh, we did. Okay. So now that we have what we call example on how to get the pH and the POH, if you're going to look at this, mostly we're able to get the pH directly of those so-called strong acids. Or if it's a POH, strong bases. Okay. So if we have these so-called strong acids and strong bases, we have a strong electrolyte. And if you have a strong electrolyte, that means it's undergo 100% dissociation. Okay. So they act like soluble salts. Soluble salt like NaCa, usually they undergo 100% dissociation. So what does it mean? Whatever is the initial concentration, that is also the concentration of your respective ions, especially if they're 1:1 mole ratio. So if you have 1 molar of NaCl, when it dissociates, it gives you 1 molar of Na plus and 1 molar Cl minus. So the same thing, if you have what we call strong acids and strong base, usually they undergo 100% dissociation. Now compare it with the so-called weak electrolyte. So when you have a weak electrolyte, only a certain percent of the given compound or chemical is dissociated. And if you're going to compare the arrow that you use for strong electrolyte versus the weak electrolyte, you will see the difference. For a strong electrolyte, is a one direction reaction. So that means it's almost going to be a complete reaction. When you have the reaction complete, there's no more reactants. All of them become products. But if you have a double direction arrow, which means the system is in equilibrium, so most likely, what will happen if you have a weak electrolyte? Okay, upon reaching equilibrium, it's made up maybe of this compound, this ion, and this ion. And in a weak electrolyte, mostly the majority, okay, or the main species that exists is this one, because only a few of these dissociate to give you acetate and hydrogen ion. So majority of the species present in a solution, if you have weak electrolyte, is whatever your starting reactant. Okay, so if you're going to apply this to the concept that we have, so if we have strong acids, they are strong electrolytes. So if you're going to look at the strong acids, this is how the reaction would be. Now the question, do you know what are the strong acids? Anyone?
One of them would be hydrochloric acid, HCl.
Okay, so if you're going to be asked if a given acid is strong or weak, okay, the technique that you need to know is all you need to do is what? Know the strong ones. And if it's not listed as one of the strong acids, you can say it is definitely a weak acid. And it's easier because there are only what? 7 strong acids. And of the 7, 4 of them are already listed here. HCl, HNO3, HClO4, H2SO4. Okay, so what are the other 3? You have HBr and HI. And what's the next one? Just one less oxygen for HClO4. So those are the strong acids. Okay, so if they're not listed here as one of them, then you know it is a weak acid. So all you need to do is know this 7, and anything that is not here is what we call weak. Okay, so the idea that you have here make this simpler because what? If you have the periodic table, HCl, HBr, and HI, all of them are found in what? A column. What group usually they are found? So this is a binary acid. Okay, so Cl, Br, and Ir. What do you call them? Anyone from Gen Chem 1? What do you call the elements chlorine, bromine, iodine?
The halogens.
Okay, they're the halogens. Okay, so 3 of them are binary acid as strong, and 4 of them are oxoacid. So the one that contains the nitrate, the sulfate, and the chlorate and the chloride. Okay, now in the halogens you have what we call HF, but it's not what we call strong acid. It is a weak acid, but it has a unique property. What's the unique property of HF? Anyone? Have you read anything about HF giving it a very unique property?
Is it hydrogen bond?
All of them has hydrogen bond. Yeah, that's what HF has hydrogen bond. That's good. But what else? Unlike the other acids, okay, when you pour them in the glass, they don't dissolve glass. Okay, but HF could dissolve glasses. That's why the rule that you have here is you don't put HF or hydrofluoric acid in glass. You have to put it in maybe a plastic container. Okay. I don't know if you're familiar with the series Breaking Bad. So when they try to dispose a body, the chemistry teacher there told one of the character to buy like a bin, okay, in a Home Depot. But what happened? He just tests himself if he fits in the bin, but he didn't bought it. He didn't buy the bin. Where did he put the cadaver and added with HF?
In the tub.
In
Bathtub.
the
The
bathtub.
bathtub.
Okay, what happened to the bathtub? After a while, it dissolved. Okay, because HF would dissolve ceramic and glass. So that's the unique property that it has. And they said the main reason for that is due to its high, the fluorine high electronegativity. But that's one unique property it has. All the acids can be poured in a glass container, but if you put HF, it's going to dissolve it. Okay? Now, weak acids are usually weak electrolytes. So if you're going to write them, you will say that there's a double direction arrow. So the hint that you have, if it's a one direction arrow, most likely it's a strong acid. If it's a double direction arrow, then most likely it's a weak acid. And again, I told you, just know the 7 strong acids, and if they're not on the list, automatically they are what we call weak. Now the strong electrolytes, on the other hand, if you're going to look at it, usually these are the so-called soluble hydroxides of group 1A and 2A. So if you have the periodic table, all you need to do is look at any of the element in the periodic table that belongs to group 1A and group 2A. Okay, and usually that's the one on the left side. And you have the lithium hydroxide, sodium hydroxide, potassium hydroxide, barium hydroxide, magnesium hydroxide. If they are soluble, most likely, okay, they are strong, what we call bases. So anything that what we call the not listed there, okay, the so-called weak bases, if you're going to look at this, these are some of them. So usually these are the conjugate bases of acids. Okay. So they are what we call weak electrolytes. They will not undergo 100% dissociation. Now, the thing that you need to remember from the relationship that you have in conjugate acid-base pair, the conjugate base of a strong acid has no measurable strength. What does it mean? So if you're going to look at here, so you say this is the acid, right? This is the base. So what do you call the Cl minus?
The conjugate base.
Base pair. This is the conjugate what?
Base.
That's the conjugate base. And this is the conjugate acid. Again, the way to know which is the conjugate acid and which is the conjugate base, conjugate acid has one more hydrogen. Conjugate base is one less. So Cl minus is one less hydrogen compared to HCl. H3O plus has one more hydrogen compared to H2O. Okay, so is that clear? If you're going to be asked question in the third exam, which is the conjugate acid of this, which is the conjugate base of this, that should be two what we call sure points on your part. Okay, so in the statement that it says there, the conjugate base of a strong acid has no measurable strength. So what does it mean? Why is it one direction arrow? Because the reverse reaction will not happen. Okay, when we're talking about strong acid, weak acid, strong base, weak base, it is measured in terms of the strength. So when we're talking about strength of the acid, strength of the base, it's their ability to dissociate. So if this is what we call one direction reaction, so that means the reverse reaction has no chance of happening. That's why it's one direction here. Okay. And then another statement that we have there, the hydronium ion is the strongest acid that can exist in aqueous solution. So what does it mean? Okay. The H3O plus here, that's the strongest acid. But it can only exist in what? Aqueous solution. So the acid that exists in aqueous solution is H3O plus, not HCl. Because what happened to this acid in aqueous solution? Anyone? What happened to HCl? What happened to HNO3, HClO4, and H2SO4? What happened to there?
100% association.
Okay, they undergo 100% dissociation. So the HCl doesn't exist as HCl when it's already in aqueous solution. It exists now as H3O plus. It's already dissociate in what we call H3O plus in aqueous solution. So that's what it means by that statement there. And in addition, the hydroxide is the strongest base that can exist in aqueous solution. Again, NaOH, KOH, and barium hydroxide, when you put them in water, they don't exist anymore. What exists is this one. And that is the strongest base that can exist in aqueous solution. Okay, those are what the statement means. Is that clear? So question. So if we're going to look at the relative strength that they have for this conjugate acid base pair, so you could see here, these are the strong acids. So its conjugate base is weaker. Now, on the other hand, the weak acid that you have, the conjugate base is a little bit stronger. Okay. Now, the main reason of this, these are what we call weaker, because all of the strong acids will give you a one direction reaction. But for the weak acid, it is a system in equilibrium. So that means if you're going to compare in terms of the relative strength, okay, the conjugate base of a weaker acid, okay, is a stronger base compared to the conjugate base of what we call a stronger acid. So what does it mean? So if I'm going to compare to you, let's say formic acid and acetic acid, okay? So based on this one, HCOOH is stronger than CH3COOH in terms of acid. Now, how does this compare? Which is stronger in terms of base between the two? Anyone?
The acetate ion will be stronger.
Okay. So since acetic acid is a weaker acid compared to formic acid, its conjugate base will be a stronger base compared to the conjugate base of formic acid. So if you're weak on this side, your conjugate acid or your conjugate base will be stronger on the other side. That's what this relationship means. So as you're going to see here, the stronger the acid, the weaker is the base. The stronger the acid strength, okay? Or we could say the stronger the acid, the weaker is its conjugate base. The weaker is the acid, the stronger is its conjugate base. So those are stuff that usually come from what we call multiple choice questions. Okay. Now, to give you an idea of this strength of the acid. So let's say here, before ionization, before you put the acid in aqueous solution, this is what you have. But after you put it into what we call solution, you don't see any of them. What do you see? H plus and Cl minus. They dissociate. So what do you think is the K value for this one? Is it high or low?
If everything is dissociating, there would be no equilibrium.
So if you're going to look at this, all of them are products. There's almost no reactants. So we could say the K value is very high. It's so high, in fact, that they don't put the K value for a strong acid. Compare it to what we call the base. So if you're going to look at the base, before ionization, you only have HF. And then you put them into an aqueous solution. What happened? Some of them dissociate H plus, F minus, and then you have HF. But what is still the major species that you see? It's still HF. Okay? What does this mean? How do you interpret this? What does this mean? So if you're going to look at the difference here, so what's the difference if you're going to look at the height?
You're gonna have a very low K value.
Okay. So if you're going to look at this, the amount that was reduced here in the HF is equals to the amount that dissociated to give you the H plus and F minus. But if you're going to compare it, it's relatively low. So if you're going to look at the the K value that you have there, you have some products, you still have the reactants. And the products is less than the reactants. So you have the K value that is what we call low. Okay. Analyze. Question. Question. Now, let's try to compare now how to get the pH of strong acid, strong base, weak acid, and weak base. So what is HCl? How do you classify HCl?
A strong acid.
It's a strong acid. How about barium hydroxide?
Strong base.
Strong base.
Okay.
So these two would
If we
go.
have this strong acid and strong base, what we're going to do? We write it, and then we write the reaction or its dissociation. And what will happen if we have an initial concentration of this 1.0 times 10 to the negative 3? Initially, we don't have it. And what will happen? We will have minus x there, plus x here, plus x here. But what is the x? Okay. It's everything, because everything dissociated. So we could say if we're going to replace this one, 1.0 times 10 to the negative 3. So at the end, this is just what?
0.
0. And this is 1.0 times 10 to the negative 3, 1.0 times 10 to the negative 3. And to get the pH here, pH is just equals to negative log H plus. And all you need to do is put whatever value of your H plus here. So this is equals to what? What do you get there?
pH of 3.
Okay, so this is equals to pH of 3, specifically 3 point. If you follow the significant figures, so you have two significant figures here. So the only
3.0.
significant figures here is after the decimal. Okay. Now on the other hand here, B, you do the same thing. So barium hydroxide dissociate to give you barium 2 plus and 2OH minus. So you have here what? 0.20, and you don't have anything. So what will happen? All of them will dissociate. And how are you going to do this one? So this is an x and this is a 2x. So what is your x here? Your x here is this one, because at the end this is 0 and this is 0.020 and this is 2 times 0.020. So by the end this is 0.040. Do you follow? Do you follow why is it 0.040?
Yes.
How about the others? Now, do you get the pH right away of this? So most likely, this is what you're going to write. And then negative log 0.040. And that is equals to what? Anyone? Please do the calculation because these are the type of questions in your third exam.
1.40.
Okay, so this is 1.40, but we're not yet done. So what do we know? pH plus POH is equals to
14.
14. So we're going to use this formula to get the pH since we have the POH. So if we're going to rearrange ourselves, pH is just equals to 14 minus POH. And we replace it there. So this is 12.60. So question. Do you think you can solve problem getting the pH of a strong acid and a strong base? That would give you around 5 points in your third exam. Question? So let's try to look at this question. So predict the direction of the following reaction in the aqueous solution. So what do you see? What do you see on this side? What is HNO2?
A strong acid.
Is it a strong acid? How about the other? What is HNO2?
Oh, no, it's not.
It's a weak acid, right? The one that is strong is HNO3. Okay. Now, what do you see on the other side? HCN is also a strong acid. No, not a strong acid, a weak acid. Now, the question being asked is, which direction is going to be favored? This one or this one? Now, you can, what we call, shoot back to me the question. Professor, how do we know to answer that question? What information do you need to tell you which direction will follow? Both of these acids are what? Weak, right? But even though they're weak, they have relative strength. Okay? So the question now is, if one is stronger, will it dictate the direction of the reaction or the other way around? So try to look back at the previous example that we have here. So this one. Look at how strong acids react. What can you say about strong acids? It's only one direction. So we could say this from this reaction that the stronger acid will be the one to dictate the reaction. So the reaction between the given reaction wherein you have HNO2 and HCN, to determine which reaction is favored, you have to determine which is stronger between HNO2 and HCN. And your basis for this is this table. So which do you think is stronger between the two? Your choice is this. And
The nitrous acid is stronger.
so the nitrous acid is stronger. So we go back to the question here. Which reaction do you think will be favored? I put here the A, the B, or it just remain the same? How are you going to answer that?
I would say A, the nitrous acid will dissociate more.
Okay, how about the others?
I agree.
Maybe I do it in a what we call poll question.
But Professor,
Yeah.
NO2 minus is the same strength as HN2O.
NO2 is the same as H2O. No, we have to
well,
look at this in terms of the acid.
I see.
I'm typing here like what we call a poll. So I can see which one is sleeping and which one is really what we call participating. So which direction is favored, A, B, or C? Because I try to relate participation to the performance of your exam. So if you're going to look at this, you're only going to compare here the strength of the acid. So both of the side has weak acids. But even though they're weak, there's still what we call the relative strength between the two. Okay? So I'm going to end now the question. So out of the 22 students who are with me, 5 students are, I think, sleeping. So these are the what we call the choices that you have. So 12 out of 17 said it's A. 4 said it's B, and 1 said it's equal. So the answer there is A. Since HNO2 is stronger than HCN, that's the one that will dictate the reaction. So it favors the left to right reaction because HNO2 is stronger than HCN. Okay. So question. Now, we have discussed how to get the pH of strong acid and the pH of strong base. What will happen if we are asked to get the pH of weak acid? Okay, how are we going to get this? Are we going to use the same way as the one that we have with the strong acids and strong base? So if we're going to look at the reaction of a weak acid, this is how it undergoes dissociation. You have HA, it reacts with water, only a certain extent of that dissociates to give you H3O plus and A minus. If you're going to look at it as HA here, dissociating itself to give you H plus and A minus, you can write the overall K expression as this one. So you have here a new K. What is Ka? Ka is just the acid ionization constant. Now, another way to know if your acid is base, if a Ka value is given, it is a weak acid. Because strong acid, as I've told you, they have K value and they're so high, so you don't write them. But for the Ka, for the weak acid, the Ka is the basis for you to identify or to know the relative strength. Okay? So if you have several weak acids and you are asked which is the strongest among the weak acid, the one that has the highest Ka value, that's the one that has the strongest weak acid. Okay? Even though you say it's weak acid, there's still a relative strength comparison of this weak acid. Right? And the way you determine which is the strongest one among weak acid is you look at the one that has the highest Ka value. So if we look at the relative, what we call sum of the Ka value that we have it here. So if I ask you to compare nitrous acid and the example that we have, hydrocyanic acid, so you could see here, this is what? 10 to the negative 4, and this is 10 to the negative 10. So indeed, your nitrous acid is what? Stronger or weaker than hydrocyanic acid? Anyone?
Stronger.
Okay. So your nitrous acid is stronger than hydrocyanic acid. And the main reason is it has a higher Ka compared with the hydrocyanic acid. So if you're given, let's say, several weak acid and their Ka, and you can be asked the question, which is the strongest weak acid, which is the weakest weak acid. Now, if you're going to look at the conjugate base of the respective one, now I will ask you the question, which has the stronger conjugate base? Hydrocyanic acid or nitrous acid? The stronger, okay, conjugate base. So you have to look here the Kb. So between the two, this is the one that you have for hydrocyanic acid, and this is what we call the nitrous acid. So which is a stronger conjugate base between the two? Cn minus or NO2 minus? Okay, so this one is a stronger conjugate base, or what we call base. Now, how do we solve weak acid problem? Okay. Now, usually the way I see the students' test paper here, I already have the basis of who will pass and who will fail the course. Okay. So the question that I have here now is, how are you going to solve it if you have a weak acid? So if you're going to solve it like this one, using, let's say, this one, then most likely you will not pass the course. This is only applicable to what? Strong acid. Although the weak acid still use this one, the question is, where do you get the H plus? Okay. So that's what we're going to do. How are we going to solve weak acid ionization problem? So the first thing that you do is identify the major species that can affect the pH. What affects the pH? Anyone? What is this, responsible for the pH? You can see it there. The one responsible for the pH is
Concentration of H plus.
the concentration of H plus. Okay. So in most cases, you can ignore the autoionization of water. You can also ignore the hydroxide because it is determined by pH plus. Now, how do you do this? Well, this is the reason why chapter 14 is the most important chapter in this course, because you're going to do the ice table to express the equilibrium concentration in terms of single unknown X. And then you write the Ka in terms of equilibrium concentration. You solve for X using the so-called approximation method. If the approximation method is not valid, you have to solve for the X exactly. And then you calculate the concentrations of all species and the pH of the solution. So to put this into practice, let's solve a problem.
Professor, can you go back to the slide one more time real quick? Thank you. That's it.
Okay. So let's now solve the problem. So calculate the pH of a 0.036 molar nitrous acid solution. Now, if you're going to give me an answer like this right away, then that's already a red flag for me that you didn't understand the question? Why is this not applicable? Anyone? Why is this is not the right solution to this question or to this problem?
Because we're
Okay.
dealing with a weak acid, and that's for a strong acid.
Okay, so this is for a strong acid and we're dealing with weak acid. Okay, so in that case, you need to identify what's the H plus that comes out of this nitrous acid. So the way that we're going to do it is we're going to look at the ice table. So what do we have here initially? Okay, we could do the rice one. That was what we're doing. So what's the initial concentration here? 0.036. So what's the initial concentration of H plus and NO2? Anyone?
0.
It's none. 0, 0. Okay. So what's the changes that we have? This is minus X and this is plus X. You still remember this for your second exam? Putting the ice table or the rice table as I call it. Are you still with me?
Yes.
Okay. So at equilibrium, what will happen? And then how do we express this? Ka equals to H plus times NO2 minus over HNO2. Or if we're going to continue, I'm going to get the Ka of the nitrous acid. Okay. So the way that you're going to do it is it's given as 4.5 times 10 to the, if we're going to look at the table that we have, 4.5 times 10 to the negative 4. And then I have there an X, I have there an X, and then I have a 0.036 minus X. Now, it says there, solve for X by the approximation method. So this is what makes it simpler compared to what you have in your equilibrium constant. So what is this approximation method? The approximation method here, that if you subtract 0.036 minus X, the answer is just 0.036 because X is so small. So that's the approximation methods that you have here, like this one. Okay. So this simplify everything because what do you do? 4.5 times 10 to the negative 4 times 0.036 equals to X squared. So X is just equals to what? The square root of whatever answer that you get from this. And what is X equals to? That is equals to your H plus. So try to solve it.
Professor.
Hmm.
So is it in every weak acid calculation that the X is very small?
That's the approximation method. But there's a rule to apply. When are you going to use this?
When I'm gonna use it?
Then you solve first. Because the only way for you to use it, you solve for the X. So please solve for the X. So what is 4.5 exponent negative 4 times 0.036? That is equals to, that what you get?
I got 4.0 times. Wait, when? I got 4.0 times 10 raised to the power minus 3.
No, we're not there yet. I'm asking if you multiply this number with this one, do you get that number? We do it step
Yes,
by step.
I got that answer. Yeah.
Yeah, and then after that, you're going to get the square root of that. And that's where you get did you get that? That's your x. Did you get that as your x, students?
Yes.
I got. Wait, I didn't get that.
I got 4.024922359 times 10 to the negative 3. So if you don't get that value, then something is wrong with the way you calculate. Everyone got that?
I'm still not getting it. I don't know why.
It's just the square root of 1.62.
Yeah, I know that's what I put.
This is what I have, right? So what do I do? Square root of the answer, which is 1.62. When I click it, this is what I got. So if you don't get that thing, so something is wrong with the way you calculate. So if we're going to do this square root of 1.62, exponent -5. So that's the answer that I have. So I don't know why you don't get that. How about the others? Because I show you how I did it with my calculator. So if you don't get it, that means something is wrong with the way you do the calculation.
I
So the
got
way
it
the
now.
calculator works,
Got to put the parentheses. That's why.
then you have to be very careful. Okay? That's why what I'm trying to do is to convince you that to do the calculation, that's the number that come out. And if you don't get it, try to fix that before we move to the next one. So you get now, why is it 4.0 times 10 to the negative 3?
Yeah.
Okay, so you get it now? So we're not done yet. So that number is your x. And that's the one that you're going to put now in this expression. Now, just to make sure you get it. So log 4.0 times 10 to the negative 3. So if you're going to look at the concentration of the species, okay? So you have here 4.0 times 10 to the negative 3, 4.0 times 10 to the negative 3, and this is 0.036 minus 0.004, giving you 0.032. So that's what it means. So what is the pH that you get here?
2.40.
So you have 2.40.
40.
Now the question, we have to determine if this is the right one, because this is what we call the approximation method that we use. We assume that X is so low. But if you're going to look at this, is this really low? So what are you going to do? They have the so-called 5% rule. If the value of your what we call X is less than 5%, then you can use this approximation and your answer is 24.0. But if the value is more than that, then you cannot apply this one. So how do we know if this obeys the 5% rule? So you're going to get the 0.0040 divided by 0.032, multiply it with 100. And what do you get? What's the value that you get?
12.5%.
How much?
12.5%.
Is it 12.5? 4.0, 36, not 32, my fault. Because 36 is the initial concentration.
About 11%.
Okay, so 11%. So that means you cannot make this assumption. You cannot make the approximation because it's over the 5% rule. So what are you going to do if that's the case? So remember the original expression like this. So that means you have to put it into a quadratic formula. So you have to put it in this form. And rearranging this one into this form, it will give you this.
Professor.
Times 10 to the negative 3. Oh, 5, not 3. So you might ask, where did I get this one? That's what I get if I put this in this form. And from that, you do the quadratic formula. And the value of X that you're going to get is either this one or this one. 4.3, negative 4.3 times 10 to the negative 3. So which do you think is the correct X there? If I
3.8.
solve this using the quadratic formula, this is the X value that I get. So what do you think is the correct X there?
The positive X.
The positive X. And if you're going to look at this, how far is your X here compared to the X that we have here? It's just small amount, right? But if this is your X, what would be your pH? So instead of using 4.0, you use what? 3.8 times 10 to the negative 3. What pH will it gives you? Will it be higher or lower pH than 2.40?
Higher. 2.5.
Is it 2.5? Can you get the negative log of 3.8 times 10 to the
Oh,
negative
wait,
3?
I calculated wrong.
2.4.
2.4, what? Somebody type. Is it only 2.4?
2.42.
2.42, because what's the sense of just putting 2.4? It's not different to the 2.40 that we have. And you could see there's a difference between the X value. One is 4.0, the other one is 3.0 times 10 to the negative 3. So see the difference that they have. You got 2.40 if you do the approximation. You got 2.42 if you get the quadratic formula. I would suggest just practice the approximation method. Chino, what is your question?
Is that me?
Yeah, what's your question?
Oh, never mind. I said already.
So the way I asked you to answer this is just use the approximation method. Okay. Because in the exam, I make sure that the X is really less than 5% of the initial concentration. Okay. So let's try another one. So here, the problem that we have solved, you're given the initial concentration and you're given the Ka. And all you need to do is determine the pH. Now, what if it's the other way around? The one that's given is the initial concentration and then the pH, and you're asked for the Ka value. How are we going to solve this problem? You can still do the ice table. It's really going to be useful here. So you have here your formic acid. It dissociates to give you H plus. And acetate, or no, formate ion. So that's the reaction. So if you're going to look at the initial, what is the initial that we have here? Point 0.1. How about the H plus? How many H plus do we have?
Zero.
Okay, you have 0. You have nothing in the initial. So what are the changes that we have? Anyone?
Minus X
So this is
for
minus
the
X.
reactant and then plus X for the product.
And then what we're going to do, we have 0.1 minus X, and then you have. Now, what is unusual with this problem? What does the pH equals to 2.39 gives you? Or what information you can get if you're given the pH? Anyone?
You can calculate the amount of hydrogen ions that are
Okay. So
present.
if you have the pH, you can get the concentration of the H plus. And from that, you can get the X. And when you have the X, aside from the H plus, you can also get the concentration of your formate ion. Are we clear on that? Are we clear on the direction that we have here? So I have a pH, so that means I can have the H plus. And the H plus that I have is the X. And that X is also my formate concentration. Because if you're going to express this one, this is how you write it. H plus COH minus over HCOOH. And if you're going to do that, that's just Ka over X times X over 0.1 minus X. Now, If you have this one, you can now have the x. Remember, what are you looking for here? You're looking for the Ka value. So once you have the x, you just supply the value of that x here, you can solve the problem. So what is H plus if you have this? How do we get the H plus given the pH? Anyone?
2.39.
So it's 10 raised to negative
2.39.
2.39 or 10 raised to the negative pH. So what is that equals to? Is it 4.0 or 4.1? What do you get? 4.0?
4.1 is more, if you round it up, it's 4.1.
Okay, 4.1 times 10 to the negative 3. So what do? We're going to use that value. And whatever you get there in the calculation, that's your Ka value. So you get what?
I got 1.75 times 10 to the negative 4.
Okay, so you round it up to two significant figures. That's 1.8 times 10 to the negative 4. Analyze. Question, class. Question.
Yes. Where did you get the 4.1 again? That's from the
That's 10 raised to the negative 2.39.
okay.
So in your calculator, I don't know what's your calculator is.
Oh, I see it. Okay. I get it. Thank you.
Usually it's the inverse of the log. So I have it like this. So I have this number, 4.7 times 10 to the negative 3. So round it up to 4.1. Or you can just do it like that, square root of that, divided by 0.10 minus the answer. So I have a 1.8 times 10 to the negative 4. So question.
I'm not getting 1.8 times 10 to the negative
It's
4.
around 1.7 something. So 4.1 exponent negative 3 squared divided by 0.1 minus 4.1 exponent negative 3. I get this number, 1.75. Try again until you're convinced that it's 1.8 times 10 to the negative 4. Now I'm supposed to give you a quiz, but when I go to my Blackboard, this is what it comes out. Service unavailable. I don't know if that's what you get also during this time. But before we started, okay, what we call setting up the class, I was able to put it there. Okay. So the quiz is some question related to your what we call exam. So don't thank God that you don't have that thing, because that means you lose the opportunity to prepare yourself for the exam. So I was able to open it. Remember when I opened the Zoom today, I didn't show up my face first because I'm trying to what we call upload the quiz that I have, but I have to open it before I give it to you. So that's the time that while we're discussing this one, it didn't what we call show up. So we will see. Maybe before the thing later on, before we're done, maybe it will be open. So it's just about the Le Chatelier's principle, some questions there of the thing. So question.
Yes, can you go over how you inputted in your calculator the Ka values to get 1.8 times 10 to the negative 4?
So I have 4.1 exponent negative 3 squared. See that? And then I divide it with 0.1 minus 4.1 exponent negative 3. And then
Hmm. I'm getting crazy numbers. Okay.
or maybe the way I would suggest to you is maybe 0.1 minus 4.1 exponent negative 3. You isolate this one. That
Yes,
will
I
give
got
you that.
I got 0.00041 when I isolated the denominator.
No, that's a minus.
Yeah, okay.
It's supposed to be that one. Or around 0.0996. Everyone has problem? Oh, by the way, if you will not be able to take the exam next week, the only time you can make it up is during our third exam, because I'm almost done with my other class. Next week is our last in-person meeting. And the only time they will show up is during exam also, during their exam. So if you will not be able to take an exam on a schedule, the only time you can make up, if your excuse for missing that exam, is during the next exam, because that's the only time I will be here in person, because my other afternoon class will be done with in person by next week. The only time that they will show up is 2 more times. That's during their second exam and final exam. So for you, you still have 4 more exams with me in person.
Wait, Professor, if we miss one exam, when is it like 2 on a day?
When you miss what we call an exam, the only time you can make it up is during the next exam. So that means you're going to take 2 exams during that day. Because that's the only time I'm here at York. So question, before we move on, the percent ionization.
Good, thank you.
So in percent ionization, we're just trying to determine how much of the weak acid dissociated to give you H3O plus and its relative anion. Okay, so this is just simply what? The X that you get divided by the initial concentration times 100. So if you're going to solve for the percent ionization in the previous problem, what would that be? So that is 4.1 times 10 to the negative 3 divided by 0.1 times 100, right? And this is just equals to what?
4.1%.
So this is just 4.1%. So the interpretation here, if you have 0.1 molar solution of formic acid, okay, 4.1% of that dissociate to give you H plus and formate ion. That's what it means in this, what we call percent ionization. So it's just the H plus over the initial HA times 100. Now, what did they observe? In the strong acid, the percent ionization is always 100, right? Whatever is the initial concentration, because it will dissociate 100%. But what they observe, for the weak acid, as the initial concentration increases, the percent ionization decreases. What does it mean? Which is more or higher percent ionization? The diluted one or the concentrated one? What do you think is the effect of dilution on the percent ionization?
It will increase it.
Dilution will?
Increase the percent.
Okay, dilution will increase the percent ionization. As you're going to look at here, as the concentration becomes more diluted, so that's the one on this going on this way, your percent ionization increases. Okay, and maybe the good example I can give you is using the same example here, but instead of 0.1, I'm going to use what? 0.01. What will be the X or the percent ionization that I have if I have a 0.01 instead of 0.1? So maybe the way that I'm going to do this here, I'm not going to use this because that is not your H plus. So I'm going to solve it with the typical solve for X problem. So if I have that, how will I do it? X times X equals to over 0.01 minus X, and this is equals to 1.8 times 10 to the negative 4. And I can make an assumption, an approximation, even though it is higher than the 5% rule. But for the purpose of determining the effect of the dilution, I just want to convince you that what would be the percentage, lower or higher than 4.1 if I have 0.01 instead of 0.1 molar formic acid?
Higher than 4.1.
Higher than that. So let's try. You try. What will be the X value if we have 0.01? So 1.8 exponent negative 4 times 0.01. Get the square root of that. I get this one, right? And if I'm going to use this, how many percent do you have? Anyone? I think somebody. So I have 13%. And what's the pH? How it affects the pH? So if it's 0.1, it's 0.39. So what will be the pH if it's 0.01?
.89.
So it will be 2.89
89.
or 2.89. The pH would be higher. Question? The objective that I have today is finish chapter 15 and then we go to review for the second exam. Question?
Can you go back to the previous slide, please?
This one?
Yes, thank you. And to get to the pH of 2.89, it's 10.
It's just the negative log of this one.
Okay. Thank you.
So I'll continue. So we have the acid. So what happens if we have the base? The same concept. The only difference is instead of a Ka, what do you have? A Kb. A Ka would be the one when you have an H plus or an H3O plus in one of the products. A Kb is one that you use when there's a hydroxide in one of the products. And just like the Ka, Kb is the base ionization constant, and the higher the Kb, the stronger is the weak base. So there's nothing difference between Ka and Kb. The only difference is Ka is for the acid and Kb is for the base. And again, Kb is one way to know that you have a weak base. Okay. So let's try to solve one problem. So solve weak base problems like the weak acid, except you're solving for the hydroxide except instead of what we call BH plus. So the Kb that we have is similar to the one that we have here. So you may ask the question, which is the stronger base? Or which is the stronger base? So the stronger base is the one that has the highest Kb value. Okay. So you're asked the question like this one. What is the pH of 0.40 molar ammonia solution? Now, synonymous to this, you should be given the Kb, which for ammonia will be equals to, using this one, 1.8 times 10 to the negative 5. So the Kb, the Ka should always be supplied unless that's the one that's being asked to be solved. Okay? So if we have this question, we also need to write the reaction. So we have here ammonia, okay, reacting with water, producing NH4 plus and OH minus. So what's the initial concentration that we have here for ammonia?
0.4.
So it's
0.
0.40. Here, ammonium ion,
0.
that's 0. This one is also 0. So the changes, do you know how to do it in preparation for your second exam? What's the changes here?
Minus X.
So that's minus X. And this one would be
Plus X.
plus X. And at equilibrium, we just bring down the initial and the concentration. So this is 0.40 minus X. This is X, and this is what we call X. And then the next thing that you're going to do is write the expression. So this is Kb equals to the concentration of NH4 plus times OH minus over NH3. And then you put the value 1.8 times 10 to the negative 5 equals to X times X over 0.40 minus X. And then again, you can make an assumption here that this is just equals to 0.40 because X is so small. It's just like if you are a billionaire, like the former guy, if you lose $1, you're still a billionaire. Okay. So if you have this, so that will give you 1.8 times 10 to the negative 5 times 0.40. And this is just equals to X squared. You assume that it's very small. And then what you do is you're going to calculate how much percentage it is to determine if it's really small. Okay, so if we're going to do that thing, if we're going to multiply this 1.4 times 1.8 times 4.4, so 1.8, 1.8, that's 3.6. 3.6, that's 7.2 times 10 to the negative, what's that, 6. Okay, and get the square root of that. So X is equals to 2.7 times 10 to the negative 3. Now, what is X here? What is this X?
That's the
X is
concentration.
your
That's the concentration of the hydroxide ion and the ammonium ion.
it's the concentration of your hydroxide ion. So that's the difference of Kb in comparison to Ka. The X is the hydroxide concentration. In Ka, the X is the H plus. So in that case, you're not going to get the H plus yet. What you get is BOH minus. So to get that, using the OH minus, you get the POH. So you have here. And this would be equals to what?
2.57.
2.57. And then you have 14 equals to pH plus POH. So to get pH, that's 14 minus POH. So this is equals to
11.43.
Now, another way to know if your answer is right, the pH should has a value that is less than 7. The POH should has a value that is more than 7. It's getting cold here. So question, before we take maybe a 10-minute break.
Professor, are we gonna check this topic check?
The what?
Check if our assumptions are true.
Oh, if you're going to check your assumption is true, so you have 2.7 divided by 0.40 and then times 100. But I can I tell you, you can just use the approximation method. So how many percent dissociation that you have there? 2.7 times 10 to the negative 3 over 0.40. How many percent is that?
It's about 0.7%.
So that's around
0.7%.
so this is really what we call small. You can always what we call, I mean, the assumption that you have is correct. So question? Before we take a break. Yeah, I need to take a break. I need to go to the restroom. So let's have a 10-minute what we call break. So what time is it? So the next part of the chapter that we have here, getting the ionization constant of conjugate acid-base pairs. So what reaction is this one? Anyone? This is the dissociation of what?
Strong acid.
Weak
Is it a
acid.
strong acid or weak acid?
Weak.
This
Weak
is a
acid.
dissociation of weak acid. Remember, these two double-sided arrow that tells you that it's in equilibrium. So that's your Ka. And then this one is just the dissociation of what we call your base. Okay? So we put it in such a way that in the base we have usually here a B, but we put it in such a way that you have an HA here and an A minus. So it's easier for us to cancel out the common things that they have. So doing that, H2O equal producing H plus and OH minus. So that is your what? What K is that? KW. So how do you get the KW? So this is just what we call a review for your exam next week. So when you have two reactions with different K, you add them together. How do you get the new K? The new K is just the what?
Ka
Product.
times Kb.
Of the K of the two reactions. So we could say Ka times Kb is just equals to Kw. So what does it mean? If Ka is given, we can get the Kb of the conjugate base of the acid. If Kb is given, we can get the conjugate acid Ka, okay, of the given base. So that's the information that we can get from a conjugate acid base pair. Okay. Now, for an instance, what will happen if we have a diprotic or triprotic acid? So when we have this so-called polyprotic acid, okay, if it's diprotic, you have 2 hydrogen available. Triprotic, you have 3 hydrogen available. Okay, they may yield more than 1 hydrogen ion per molecule. So the way that you're going to do them is you ionize them in a stepwise manner. They will lose one proton or 1 hydrogen at a time. And in that case, you have an ionization constant written for each ionization state. So what does it mean? You have a Ka1, Ka2, or Ka3. Okay, so you're going to have 2 or more equilibrium constant expression. And you use this to calculate the concentration or species of the solutions in the what we call acid solution. So for instance, we have carbonic acid. So the first dissociation, you have a Ka1. And then your HCO3 here will dissociate further to give you H plus and CO3 minus, giving you the Ka2. Okay. Now, if you have problem like this, you have to do the calculation in all steps. So for instance here, you have oxalic acid used chiefly as a bleaching and cleansing agent. You are asked to calculate the concentration of all species present at equilibrium in a 0.1 molar solution. So what does it mean? You're going to calculate all the form of this what we call oxalic acid. So maybe you can start with the first one. Okay, so if we're going to look at this oxalic acid, so that's the one that you have here. So this is your what Ka? Ka1. Now how about the hydrogen oxalate ion? What do you call that? So this is what it forms when 1 hydrogen is given off. So that's your Ka2. Okay, so look at the value. What can you say about the value? So one is a -2, the other one is -5. So there's a difference in the degree of the strength. Now Ka1 is usually higher than Ka2 because that's the one that will dissociate first. Okay, so to solve the problem that we have, we're going to write the reaction. And this will dissociate to give you what? So that's aqueous. So you have an H plus, that's aqueous, and an HC2O4 minus, that's aqueous. And I can do a 0.1 here, right? Reaction, initial changes in the concentration. And I don't have anything here. Then this is minus X, and this is plus X. And you have here 0.1 minus X, and this is X and X. So how do I express this? K A1 equals to H plus HC2O4 minus over H2C2O4. And I'm going to use the Ka value that I have here. That's 6.5 times 10 to the -2. Is that 2 or 4? Okay, that's 2. And again, I can make the assumption. Just do it. Okay, we may not obey the so-called 5% rule. I just want to simplify your life. Okay, and I can bet you on your exam, you're going to make your life complicated. So simplifying it, this is just 0.1. So if you have it, you have 6.5 times 10 to the negative 2. So this is 0.1 and this is x squared. So the x that we will get here will be equals to what? So this is 8.1 times 10 to the negative 2. So what is this equals to?
The concentration of the hydrogen ions.
So that's your hydrogen ion. Okay.
And the concentration of the
And then the H2C2O4 minus. Now, the problem with this one is what? If you're going to do the approximation, what do you think is the percentage dissociation here? So this is a 6.5 times 10 to the negative 2. So if you're going to do this approximation, you're going to get around, if you're going to do, this is what, 8.1. So this is just really so high. So this is 0.081 divided by 0.1. So that is an 81%. Now, if we use quadratic formula, I will just give you what we call the x. The x that you will get will be around this one. I just show you the difference. It's really different, right? So I'm just trying to simplify this thing, right? Because if we use this quadratic, what we call the approximation, it's just 8.1. Now look at the difference. So let's assume we just use the 0.054 because we're not done yet. What we have so far is just the concentration of what we call your H plus, your HC2O4 minus, and this one. So let's assume it's 0.054. So what is 0.1 minus 0.054? Because we want to get the species at least after the first ionization. So that's 0.046, right? So that's the concentration of that. H plus and HC2O4 minus, that's the concentration of 0.054. But we're not done yet because your HC2O4 minus can still dissociate to give you more H plus and C2O4 2 minus. And you're going to use now the volume that you have or the concentration that you have from the previous one. And this is not 0. This is already what? 0.054. And this is 0. Where do we get the 0.054 here? For the second ionization, we get it from
X.
the previous ionization. So the first hydrogen was dissociated first. So when they dissociate, that makes you have a hydrogen that's available for the second dissociation. Now there is what we call a hydrogen oxalate that's formed there. So that's the one that you do. You repeat the process. So this is minus X, this is what? Plus X, and this is plus X. And then you end up with this. So you have a plus X here and you have a minus X here. And then you can do the same thing as the one that you did, but this time is Ka2. So you have the H plus there times the H no, not the H, that's a C2O4 2 minus over the HC2O4 minus. So we're going to replace it with what we have here, 0.054 plus X, and then X. And then this one is 0.054 minus X. And what's the Ka2? If we're going to look at it, 6.1 times 10 to the 5. To the negative 5. So how do we simplify this? We can cancel the X here, assuming that they are so small. And if we have that, what do we have? Same number here, right? Do you see that? That we can just cancel this one, and your y is just equals to 6.1 times 10, or maybe it's still the X. Negative 5. Now you can what we call make another assumption, I mean the approximation to check. So 6.1 times 10 to the negative 5. That's what we call the value that you have divided by 0.054, the initial concentration of that. What do you get?
.11%.
So you have 0.11%. So that's this value. So the question now is, what is the concentration of your H plus, your HC2O4 minus, and your C2O4 2 minus? So the way I'm going to do it is I can start with this one. So I have here what? 0.054 plus the 6.1 times 10 to the negative 5. And this one 0.054 minus the 6.1 times 10 to the negative 5. And this one is just 6.1 times 10 to the negative 5. And what else? I think I can still also have this one, the H2C2O4, which is now 0.046. So I would say the H plus and this H2C2O4, this is just so small. So that's just the concentration. So those are the concentrations of all species present in equilibrium.
Professor, where did you get 0.046 from?
What?
0.046.
I subtracted this one because the X that I have is 0.054. So I've subtracted it to 0.1. So I get 0.046. So question, before we look at the effect or the factors that affect the acid strength. So we could say the calculation part is a little bit done. The only one that we have is later on when we go to the salt. So question, I think some of you are still copying this one.
Professor, did you cancel out 6.1 times 10 raised by minus 5 because it is a small number?
Which one? Yeah, I cancel out because it's so small.
Okay.
It's 0.0006561. So it's just so small. So there's still another calculation, but the next one that we're going to do here is, wow, how is your acid strength affected by this so-called molecular structure? So how do you know which one is relatively stronger, okay, with one another? So let's say we have two strong acids or two weak acids. How do you know which one of them is stronger? Okay, so the first thing that we're going to look in terms of the structure, the stronger the bond, the weaker the acid. Why? How do we define the strength of the acid? If you recall,
When it gives an H plus.
so it gives an H plus. So the stronger you hold your hydrogen, okay, the weaker it is of the acids, the more likely it will not give up its hydrogen. So if we're going to compare those in the halogens, okay, so this is how they would look like. The acidity increases as you go from top to bottom. Why is HF the weakest one? What makes HF the weakest among this group? And how is it that the acidity strength increases from top to bottom? How do you define fluorine? Fluorine is what? The most
It's the most electronegative.
atom. So if you have the most electronegative atom, you want it for yourself. So the bond of this HF is so strong. That's why the hydrogen is not available. But what happened as you go from top to bottom in terms of size? If you recall your Gen Chem 1. As you go from top to bottom, atomic radius or atomic size increases, decreases?
It increases.
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 So what happened if your increases? So most likely, the bigger that you are, is it the stronger the bond that you have? Usually, the bigger that you are,
The more distance there is
the more distance it is, the weaker
between
is the bond.
yes.
And if it's the weaker is the bond, the stronger is the acid. So that's what it means here. Okay. So if you're going to look at it, iodine. Okay. So if you are within the same group, you compare the size because iodine is larger, HI is stronger than HBr. HBr is larger than Cl though, so HBr is stronger than HCl. Okay, now how about if you're going to compare HCl versus H2S? And to tell you frankly, this is where the S is. So which do you think is the more stronger acid there? Okay. So for comparison purposes, HCl is stronger acid compared to what we call the H2S. But the thing that what we call stronger to look at it is in terms of the within a group. Okay, the larger the acid, the stronger it is. How about if I put the oxygen there? Which do you think is a stronger acid, H2S or H2O?
H2S.
Okay, so H2S is stronger than H2O. Now, if we're going to look also at the acid-base properties of salt, we're going to go on that over. I don't know why this comes first here. Because the next thing that we do is, how about the oxoacid strength? How does molecular structure affect oxoacid? So oxoacids are the one that contains oxygen. So what do we say? Oxoacid having different central atoms that are from the same group and have the same oxidation number. So it says here, acid strength increases with increasing electronegativity of Z. So which is stronger between the two? Based on this, what we call statement. So chlorine is more electronegative than Br. So that means this is stronger compared to this one. HClO3 is stronger than HBr. So the thing here, this is the other way around. Okay. And what is usually my reminder for this? This is a strong acid, but this is not a strong acid, and this is not a strong acid. That's the way I'm reminded by this one. Because Cl is stronger than, or we could say, it's more electronegative than Br. So if I have it like this one, which is more stronger if I have it like this? The hypochlorous or the hypobromous acid? Which one is stronger? Anyone? Which is stronger here?
The hypobromous would be stronger.
This is this one.
Hypochlorous.
Okay. So following this thing, Cl is more electronegative with Br, and you have an oxygen there. So HClO is stronger than HBrO. Okay. You just follow that thing. Now, the other one that we have here is, what if they have different? So we already discussed about C being very electronegative. So the OH1 will be more polar and easier to break if C is very electronegative, or C is a higher oxidation state. So what does this mean? Which is the strong acid between the two here? Nitrous or nitric? How will I put this one in terms of strength? Less than, equal, more than? Nitrous acid is less than, more than, or greater than? Less than, equal, or greater than nitric acid in terms of the strength?
Is it less than?
It's less
Yeah.
than. Why? High oxidation state. How will I know that this has a higher oxidation state? The number of oxygen. Because if I'm going to get the oxidation number of N here, most likely this is equals to what? 1, 2, 3 times 2, that's 6. So this is a plus 5. 1, 2, that's equals to 4, plus 1 here. So this is a plus 3. So in terms of the oxidation state, the higher the oxidation state, the stronger is the acid. Okay. The same thing with this one. Sulfuric acid is a strong acid, while sulfurous acid is not. Because the sulfur oxidation number is higher in sulfuric acid than sulfurous acid. So this is an H2SO4, the sulfuric acid H2SO3, that is your sulfurous acid. Another thing that we can look is oxo acid having the same central atom, but different number of attached group. So acid strength increases as the oxidation number of C increases. That's the explanation that we have there. So if you have it like this, so this is the strongest one, followed by this, and this is the weakest. So let's try to predict the relative strength of the following. So I think we answered already this one.
Professor, could you go back for a second, please? Thank you.
So how do we predict this thing here? So which do you think is the strongest one? The ClO, the HClO, or the HIO?
The HIO is the strongest.
Hmm?
The HClO.
So see this one here? Acid strength, no, that's not the one here. It should be this one. Acid strength increases with increasing electronegativity of C. So which is the most electronegative? Chlorine or iodine?
Chlorine.
Chlorine. So that means that's the one. The only one that the iodine will be strong is if you're not an oxo acid, if you have it in this form. Is that clear? This is true for a binary acid, but for an oxo acid, the more electronegative is the one that is the strongest. Most likely, these are some multiple choice question that will come out. Okay. So question, before we go with the salts.
Can you go over the oxidation number, please?
So in terms of the oxidation number that you have here, okay, so the way that you're going to do the oxidation number, you're just going to look at the charge. So that's 0. And then between this one, the oxidation number that you know, oxygen is always a -2. You multiply it by 4, so that means you have a -8 there. Hydrogen is always a +1. So to get the oxidation number of chlorine, you add them together in such a way the total charge is equal to 0. So you find a number for this chlorine, when you add it with the other number will give you 0, and in that case that's 7. You will have what we call things like this in electrochemical part. But here, the way that you look at this, the one that has the highest oxidation number is the more oxygen that you have. The more oxygen that you have, the higher is the oxidation number of your central atom, the C. So you have 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen.
So the oxygen, the number of oxygen is in proportion to the oxidation number.
Yeah.
Thank you.
So if we're going to look at this one, So the more oxygen that you have, the stronger is the acid, if you have an oxo acid. And the more electronegative is the central atom that you have, the more stronger is the acid, okay, the oxo acid. So the last part that we have is the salts. So you get to determine the pH of strong acid, strong base, weak acid, weak base. So the last part that you need to know is, what if we have salt? How are we going to determine the pH if we have what we call salt? So for a neutral solution, it's easy. Usually, if you're going to look at the salt, like this one, some part of them came from an acid, some part of them came from a base. So where do you think the Cl minus came from?
HCl,
HCl, which is
a strong acid.
a strong acid. And where did you think Na came from?
NaOH.
From NaOH, and this is a strong base. So you have a conjugate base here and a conjugate acid. So Cl minus is the conjugate base of HCl. Na plus, okay, is the conjugate acid of your NaOH. Okay, or we could just say the conjugate there, as you could conjugate base of a strong acid, the one that we have here. So both of them coming to the strong one. So when they dissociate, they give you Na plus and Cl minus. And they will not dissociate. They will remain as Na plus and Cl minus. So they will be neutral solution, or another way of saying it, strong base, strong acid, they neutralize one another. Now compare it to the one that came from this type of salt, a strong base and a weak acid. So this comes from NaOH, which is a strong base, and this one comes from CH3COOH, which is a weak acid. So whenever you dissociate this one, you're going to have a basic solution because the component of your base is stronger compared to the component of your acid. But there's another way for you to look at this reaction. What happened? Your acetate will dissociate with water or will react with water to produce acetic acid and hydroxide. So this is what? That caused the basic solution. Or the way that you're going to what we call describes this, if you have a conjugate, in this case, base from a weak acid, what will happen? That conjugate base will react with water to produce hydroxide. But the way I ask my student, if you're asked what is the basic, what can you tell about the salt, or which salt is acidic, which salt is basic, which salt is neutral? You just have to break down the salt and try to find where the source came from. Okay, if the source is from a strong acid and a strong base, then you have a neutral solution. If the source is from a strong base and a weak acid, then you have a basic solution. So let's try to work on questions like this. So what is the pH solution, or what is the pH of a 0.15 molar solution of sodium acetate? What is the percent hydrolysis? So the question is, what will be the solution for this one? Will it be acidic, basic, or neutral?
Basic.
Basic.
So it's basic. So the pH should be what? With respect to 7. More
No, no,
than, less than, equal to 7.
more
Greater
than.
than.
It should be greater than. So how are we going to solve problem like this one? So you have the salt. What usually happens with the salt when you put them in water? They are going to dissociate, giving you, oh God, CH3, COONA. So they dissociate, maybe give you CH3COO minus and Na plus. So initially, what do you have there? 0.15. You don't have anything here. So the change that you have, you're going to lose the 0.15. And it's going to form 0.15 and 0.15 because it's a salt. So at equilibrium, or we could say the final concentration there, all you have is this one and this one. Now, which one of that hydrolyze? When you say hydrolyze, when it reacts it with water, it produces a reaction. Na plus, when you put it in water, will there be a reaction? What happens if you put Na plus with water? It's still
Na plus.
Na plus and water. But what happens if you react CH3COO minus with water? What will happen?
It accepts an H plus from water.
So it's going to get the H from the water, giving you acetic acid and hydroxide. That's why you're right that the pH is more than 7 because you have there a hydroxide. But the question is, how are you going to solve this? So what's the initial concentration now of your acetate? Anyone?
0.15.
That's 0.15 coming from here. You don't have anything here. You don't have anything. And then the typical thing that you do, minus X, and you have plus X, and you have what we call plus X here. And then at equilibrium, you have 0.15 minus X, and then you have here X. Now the question, what's the K that I have for this reaction? Ka or Kb?
KB.
KB.
How about the others? Why is it Kb?
Because we're trying to find a concentration of OH.
Okay.
A basic solution.
Why is it Kb? Because we have an OH minus here in the product. And if we're going to write it, we will be like CH3 COOH times OH minus over CH3 COO minus.
Professor,
Yeah, what?
why did you just put 0. Why didn't you solve for X and the first one?
We don't solve for X for this one because this is a salt.
Okay.
Now the question, do we have the Kb of the what we call acetate? Do we have the Kb for the acetate? Yes or no? What
It
do
should
we
be
have?
given, right?
The one that should be given should be the Ka. The Ka of acetic acid, because that's the acid. That's 1.8 times 10 to the negative 5. So how do we get the Kb? We get the Kb from the relationship of Kw over Ka, and that is just what? 1.0 times 10 to the negative 14 divided by 1.8 times 10 to the negative 5. And what do you get there? What do we get there? 1.0 times 10 to the 14 divided by 1.8 times 10 to the negative 5.
5.6 times 10 to the negative 10.
So 5.6 times 10 to the negative 10. So that is now your KB here. Then what do we have? X times X over 0.15 minus X. So we can make the assumption that this is just equals to what? 0.15. So what's the X that you get there? Now, I want you to do it yourself now, because we're solving for X since we started our class this morning.
Professor, sorry to interrupt. How did you get KW again?
KW is given as 1.0 times 10 to the negative 14. Remember the relationship here? This one.
Yes.
So KW has always a value of 1.0 times 10 to the negative 14.
Okay, thank you.
So what's the X that you get there?
9.1 times 10 to the power negative minus 6.
9.2 or 9.1
9.2, sorry.
times 10 to the,
Minus 16. No, minus 6, sorry.
everybody got that? The others?
Yes.
And this is equals to what? Is it the H plus or the OH minus?
The OH minus.
OH.
So from that, you can get the pH. Oh no, the POH. And that is equals to what?
5.04.
5.04. So to get the pH is just equals to 14 minus 5.04. So you have here 8.96. Now the question is 8.96 higher than 7?
Yes, it is.
Yep. So you answer the first question now, the pH. Now, how do we answer the percent hydrolysis? So we get the X value here, 9.2 times 10 to the negative 6, divided it with the initial concentration, which is 0.15, and multiply by 100. And that would be equals to
8. Wait, Professor, how did you say we're going to solve this?
somebody mute whoever's got. Okay, yes, the question?
Professor, how do you say we're going to find the percent hydrolysis?
So you get the X there value divided with the initial concentration. So
I
the
got
x is 9.2 times 10 to the negative 6 divided by 0.15. So times 100. So that's the percent hydrolysis that you have.
I got out the 0.006%.
Yep. So 0.006, I think 1%, the answer that you have there.
So is it like solving for the confirmation or something?
No, it's asking for it.
Oh,
So you're asked how much of the 0.15 was hydrolyzed. So the one that hydrolyzed is the one that forms the OH minus. So if you're going to look at this, 0.00661% is just so small. So that's the amount of the anion that hydrolyze. Then it also means that our approximation is valid because the percentage is so small, less than the 5% rule that we have. So what we're trying to do here is just, okay, if we have a salt, we want to determine what's the pH of the salt. So we look at the component where the salt came from. Because salt is just made up of what? Cation of a base and anion of an acid. So where this cation and anion came from, we can predict what will be the solution of the salt pH. So here we said this is going to be basic, and the pH that we have 8.96 confirm that it is indeed basic. How did we say it is basic? Because we have a sodium acetate. Acetate comes from a weak acid, sodium comes from a strong base. And acetate will hydrolyze, okay, with reactive water to produce hydroxide ion, while Na plus, when you add with water, it just remains as Na plus. So to end up this section here, so we already have the neutral and the basic. So how about the one that forms acidic solution? So this is the one, this is the salt that comes from a strong acid and a weak base. So if you're going to look at this, so you have ammonium chloride. So this one comes from weak base, which is ammonia. Cl comes from HCl, which is a strong acid. And also when you look at the ions that form, put it in water. If it dissociates, then most likely, okay, whatever that forms there, you can have an H plus or an OH minus. That will predict what solutions you will have. So here in the ammonia that you have, when you dissociate it, it forms NH3 and H plus. If you put water on it, so this is in the form of H3O plus. Now, another thing that they have with the what we call acidic solution is one when you have this so-called metal. So when you have a metal, most likely you're going to form an acidic solution. So any metal cations, when they dissociate, they will give you an H plus or salt that contains metal. When I say metal, it's the transition metal. Okay. Now, when we summarize what we have, we can look also at the Ka value. Okay. Oh, this is the one wherein both of the cation and anion comes from weak acid and weak base. So to do that, we look at the Ka and the Kb. So if the Kb is greater than the Ka, the solution will be basic. If the Kb of the anion is lower than the Ka of the cation, the solution will be acidic. If it's both the same, then the solution will be neutral. Example of this is, let's say you have this ammonium acetate. So both of them came from NH3, which is a weak acid or weak base, and acetic acid, which is, so all you need to do is determine which one is higher. Without knowing the Ka, without the given Ka and Kb, you cannot answer the question. The question that you will have in this type of salt problem is just typical question like this one. Which one will be acidic? Which one will be basic? So NH4I, is it acidic, basic, neutral? How do we break this down? Where does the I came from? Ammonium ion is weak base. Now how about iodide? What acid is it? Strong, weak acid?
Strong.
HI.
Strong.
Strong. So what it is? Acidic, basic,
Acidic.
neutral. So that's an acidic one. Because the strong one comes from the acid. Now how about this one? Acidic, basic. So you have an NO2 minus, which is from a weak acid. You have an Na from a strong base. So this is basic. FeCl3. So as I told you, if you have a transition metal, it's always going to be acidic. Now this one. So this is a case of ammonium ion coming from a weak base and HF coming from a weak acid. So we need to look at the Ka and the Kb value. So for the Ka, so the Ka that we have here, this is 5.6 times 10 to the negative 10. And the Kb value is 1.4 times 10 to the negative 11. So which one is greater?
Ka.
So, acidic, basic, neutral.
Either acidic.
It's acidic. So I will wrap up chapter 15 after our exam next week, and then we proceed with chapter 16. Because I like to discuss, maybe we go over the problems that I have posted to you in your Blackboard. And the Blackboard is now what we call accessible. The quiz that I have are just 5 multiple, no, not 5 true or false questions. So I'm giving you 1 minute for each statement to answer it true or false. So questions so far before we start with the review.
Oh, never mind. You done? Oh, yeah. So, never.
Yes.
So if we see something that is like a neutral solution, if we see something like, yeah,
Come again?
if you give us something that's like a neutral solution, we should first check the Ka and Kb values, right?
Yeah.
Oh.
The quiz will be due before 1. It's just a 5-minute quiz. So I don't think it will take you what we call longer than that. There's just a sense of statement there, and you will say if it's true or false. That's it.
Is it the quiz that says chapter 14 to be
It's
correct?
the chapter 14 quiz. It's to prepare you for your exam. And then during the week after today and before you take the exam, there will be like a dry run for your second exam quiz.
Professor, for the quiz, it's saying the service is unavailable.
Hmm?
For the quiz, it's saying that the service is unavailable. We cannot open the quiz.
Try to do
Or
it
I
now.
Yes, I am trying it now. I don't know. Let me double check.
Because I just what we call open the thing that I have here.
The chapter 14 quiz is not letting me open it. It's saying it's past due.
It's not yet done. The chapter 14 is done. The one that we have there is this one. Quiz 10.
We cannot see this one in our
Yeah.
Blackboard.
Yeah, it's not on mine either.
Yes, mine either.
So maybe I'll just open it until 5 o'clock today, or just let me know if it's still what we call not open, that I'm not going to open it for the whole week. Okay. So I can change maybe the due date here, but I want you to take it as soon, because if it's not available with you, how come I can access it? Because if it's
Cause on our side, the last quiz we can see is the chapter 14 quiz. After that, we cannot see nothing.
no, because I have not opened yet the quiz.
Oh.
If you're going to look at this here, so you have a different view than me.
Mm-hmm.
Okay, so if you're going to look at on this side here, you see that item is hidden from students.
Oh, okay. Now I get it.
I usually open it earlier when usually our quiz is during the break. So usually I open it to that. So it's hidden for now because I have not opened it yet. Because the way I do it is just make it available if I make it available. Okay. I just have to take a call, okay? I don't know. It's an unknown one, so maybe. Sorry for that. Just telling me that my Amazon account is compromised. Commerce. So I'm going to open it later on, okay? So have you gone over the problem set? Because we're just going to talk about the problem set. Because I think that's the best way for you to prepare for the exam. The quiz is still due at 1 o'clock, okay? So if we're going to what we call, just to give you the possible thing that will come out. So I'm like trying to summarize what we have so far. So I'm just going to turn off my video because I have to get my lunch before I meet my other class. So what did we discuss in chapter 13? What's the problem that I asked you that you need to know? Remember that? You still remember that?
Yes.
So you're going to have a problem like that one. So I would suggest you go over the video that we have for chapter 13. Okay. And then you have to know the zero, first, and second order integrated rate law. Are you familiar with this? So you will be given there if it's a first order, a zero order, or a second order. So your objective is to know what is the formula. So just to give you an idea, if you said, where can we find this thing? So I'm going to go back to the blackboard. So you see the blackboard? So you see this one? Final exam formulas and equation. So I try to share. So I think you need to learn the stuff here. You're seeing the document? Because the thing is,
Hello, Professor. Professor.
yep,
For the quiz chapter 4, you didn't open it, correct?
I have not opened it yet. Okay, that's why I want your
Okay.
attention to be here with me. I will open it before we leave, okay, for the day. You only need 5 minutes for the quiz. Because right now, I need your attention for you to prepare for the exam. That clear? So you need to know this one. These are the equations that you will need to know in your second exam. Not included there is the rate law. You know the rate law? Rate is equals to K, concentration of A, raised to the X, times concentration of B, raised to the Y. So I think overall you will get there, if I'm not mistaken, 20 to 30 points. I want you to go over the problem set. I'm trying to open at the reviewer that we have. So you follow? I open the reviewer now. Do you see the reviewer, class?
Yes.
Yes.
So there are some problems there that is first order, second order. I want you to work on them. Like this one, the initial concentration in the first order is 0.27. The rate constant is reaction. This one, what is the concentration after 1.5 seconds? The question is similar to that. Don't be confident when I tell you that the second exam is the easiest exam. Okay? Because you cannot be confident, especially with the score from your first exam. History has just shown me that the students are doing well in second exam. After let's say an average of around 60 in the first exam. Now, the thing is, because everything was given to them, so that's what you're going to do. Work on the problems that you have here. Master it, okay? Don't memorize, because if you memorize, you ship something, you get confused. So I want you to manipulate the equation. If you're going to look at the equation, so this is the one that you have. So try to solve it in such a way. What if I'm looking for K? What if I'm looking for T? What if I'm looking for the initial concentration? What am I looking for? The concentration after time. That's how you attack problem in this portion. Okay? Because the second exam is, we could say, one way to tell me if you need to stay, or I advise you to just drop the course. If you don't do well here, most likely you don't even need to ask me if you need to stay in the course. The average of this exam is usually around 70 in the previous semester. So ask yourself, if you're able to solve problems or understand the question that you have in the reviewer, can you solve problems similar to that in your exam? And I already posted also the answer key for this that contains the solution. So in the rate law, most likely you will have a question similar. Let's say, where's the rate law problem? Maybe this one, the first order, the second order, like this. Number 3. Yes, Chino.
Professor, I have a question. When do we use the rice stuff? Because I don't know.
You're going to use it when you do to the chemical equilibrium. You have to set it up in such a way you know what is happening during the reaction. We're not there yet. We're still in the what we call kinetics part.
I have a question about question number 5 when asking about half-life. When do you have office hours? Because this question gives me like a lot of trouble.
What is the value of that's the value of K.
Huh?
Is it number what? Number 6?
5.
Oh, number 5. So yeah, I think there's some mistakes on this one. If I'm not mistaken, the answer here would be what is the time when you get 1/2 of 1.22? So how long does it take for 1.22 to be 1/2? That's the half-life.
Is it 6?
Yep.
6 seconds?
Yep, that's the answer. Because I think this is a 0.86 here. The mistake that we did before, I mentioned before. So if you're going to ask a half-life question and you have the raw data, all you need to do is find the time for the concentration to be at least 1/2 of the initial concentration.
So you can divide the concentration of the initial concentration of A by 2?
Yeah. 1.22 divided by 2 is what?
0.61,
So how long it take to give you 0.61?
6 seconds.
Now, another question that can be asked in the kinetics will be, remember the mechanism? Remember when we have this like reaction 1, slow, reaction 2, fast, and then maybe you will ask what's the overall reaction, if there's an intermediate, catalyst, and then you're going to write, let's say, the rate law based on the mechanism that you have. So that's a 10 points problem that's being asked. Yep, the slow one is the rate determining step.
Professor, for number 6, is this the question you said did not have the correct answer?
It has the wrong given answer. I mean, given what we call number. So instead of 0.66, it should be 0.86.
Oh, that was question 5, not question 6.
That should be a 0.86 there instead of 0.66.
I'm sorry, are we talking about number 6 or number 5?
Number 6, because number 6 is talking about number 5.
Yes.
So if you're going to look at the solution key, I use there the value of 0.86
I see.
because the original given one is 0.66.
Oh, okay. So solving for 0.66, my calculation gives me 0.18 seconds.
But the answer there should be 0.12. Because I told you the given that should be there is 0.86, not 0.66.
So then negative k would be 0.86 divided by 1.22 divided by,
Here,
oh, yeah. Okay, minus 3, right.
I want you to go over this reviewer, okay? If you understand what you have here, you're going to survive the exam. If not, we will meet maybe on, I'm going to make myself available on Friday at 10 o'clock. I'll just posted the Zoom links.
Is that your only office hour?
That's the only office hour that I have, unfortunately. You can always email me if you have questions.
Can you go over number 12?
Here, so you just ask what's the graph. So you should know the formula here. So the graph here, what is this? First order, second order, or third order? So this is just knowing what the formula would be like. So this is the first order. So what is your slope? If you're going to look the formula, this is what you have. So first order, this is what comes out. So what's the slope here? It's a negative 3. Right? Is that the answer? So if you're going to look at this is number 12. See, there. So email me if you have any question, and if we can meet outside the office, or I can set you. I mean, if you send me a time, we can meet on that. We will. I'll try to see if we can meet. But I would suggest you start with this reviewer. Even the what we call the what chemical equilibrium part we're going to do. Meet in person if you want. You I only come here every what we call Saturday. We might meet only virtually if ever.
Could you quickly go over 14? Sorry.
Yeah. So remember when you have a first order, a second order, a third order. I think we did this when we are in person. So what do we have there? The plot.
So it would be A versus time.
So I think this is a 0 order. This is a first order. And this is a second order. And the plot of this, I think, is both down, right? Well, this one is going up. So what is the number? What number is that you asked?
14.
So first order, so a plot of which would produce a straight line for this reaction. So this is a first order, so a plot of that would be ln of A versus time.
So if it was a second order, it's gonna be D, right?
Second order would be letter C.
C.
No. Letter B.
Okay.
Remember, the second order is what? Time versus 1 over
Mhm.
the concentration of A. So if you're going to look at the choices there, letter A is a first order, letter B is a, letter A is a 0 order, letter B is a first order, letter C is nonsense, letter D is a second order. So that's the possible 4 problems coming from the kinetics or chapter 13. Okay, the rate law, the integrated rate law 2 problems, and then the mechanism. So that's already how many points? It can be 30 to 40 points. Okay. Now, for the what we call equilibrium, you're going to have one big problem, 20 points. I think it would be similar to like 29 problem. Oh no, 29 is an easy one. It's the one that is you solve for X or you solve for the concentration during the equilibrium. So I want you to go over, and as a promise, it will be a perfect square question. So you don't need to do quadratic formula.
So that's gonna be similar to number 36, maybe?
Yep,
Okay.
the question would be similar to 36. And I think number 36 is also a perfect square,
Perfect
am I right?
square. Yes.
So included in the 20 points, I may ask you to get the Q or maybe the KP. So the technique is you don't want to leave any blanks. If you're the type of students who still leave any blank, I would suggest make this course blank for the rest of the semester. Because I cannot help you if it's still going to be a lot of blank. And then the other question that can be asked that's worth 10 points. So let's say we have, let's say, this reaction. That's right, 3. Just assuming that this is the reaction. So what's the question that's going to be asked? So this is a positive one. So you have like stress here, and then you predict shift, and then let's say effect on N2 concentration. So let's say I do it like this, this, so how are we going to answer this? So how do I put the shift here? So it could be forward, backward, shift to the left, shift to the right. And then effect on N2, it could be increase, decrease, or no effect. So what's the answer here? If it's like this. Increase in pressure, what will happen? Which reaction will be favored?
The forward reaction.
Okay. What will be the effect on N2? It can be arrow down, arrow up, or the same.
Arrow up, increase.
Increase.
Effect on N2?
No, it's going to
Oh,
decrease.
decrease.
If the forward reaction is favored, you're going to use up your N2, so that will be decreased. Is that clear?
Yes.
Clear.
Temperature.
Reverse.
If there's an increase in temperature, and this is what, exo or endo?
That's endo.
Endo. So which reaction is favored?
The products are going to be consumed.
Huh?
It's going to go to the left.
How do we look at the temperature or the heat? We treat it as one of the
Positive.
reactant or one of the product. So where is heat in this reaction? Reactant or product?
The reactant.
Reactant.
Okay, so if
Oh,
you increase
it's
this,
gonna
what will
go
happen?
forward. It's gonna go forward.
That will go down. Decrease in H2.
Backwards.
And what will happen to N2?
Increase.
You're replacing the H2 and at the same time you're producing more N2. What's the effect of the catalyst? Hmm? What's the effect of this one?
It will produce the reactants N2 and H2.
It will not shift any of the reaction. It will just make it faster on both sides. So there's really no effect. And this one is just be the same.
Oh, I was looking in terms of NH3.
Now for the NH3, you increase it, what will happen? Which one is favored?
The backward reaction.
The backward. And what will happen to your N2?
It'll increase.
It will increase. So you have a question like that. So do you think you're ready? Again, I will try to be here by 8:30 next week. So I hope what happened today will not happen next week. I think I really have a bad day. I was leaving home and it's raining, so I have to go back home and get my umbrella. And then I went to the station, and then all of a sudden the power in the train went out and announced that there's some police activity in Forest Hill. So we waited there, I think 30 minutes until we were allowed to go. I arrived here past 9, set it up. So I don't know. So I'm going to open now the quiz. This is just a 5-minute quiz, so everyone can take it before 1. So it's now available. So if you have any what we call question, you can email me. Now, my suggestion is email me tomorrow, because usually if you email me today, after my class this afternoon, I'm just so tired. Okay. So the way I do it is, if ever I open it, most likely I forgot it. But at least if it's on the Sunday, I open it. So I said, okay, I will answer it, because sometimes when I open it nighttime and I arrive home, I forget it, and I'm thinking it's maybe I answered already the email. But most often or not, I forget to answer, because my schedule during Saturday is from 9 o'clock to 6 o'clock. But the thing is, as I've told you, by next week, our in-person class will be done in my other session. So if you're going to miss for good reason the exam, the only way you can make it up is by the next exam. Because the only reason I'm here in York is because of your exam and the in-person class that I have. But unfortunately, our in-person class will be done because some of the instrument that we're supposed to do will not be working. So we don't need to go here and do the experiment. Okay? Now I want you to, what we call, if we're going to look at the thing here, I can monitor how many of you are watching the video, because if we're going to look at the course material, so you have here the recorded class video, but what I did, I cannot upload them directly here. So what I did is I just post the link. And in the link, I can determine how many of you view it already. So like this one, 13 views. Okay, the other one, 11 views. So you are at least what, around 20 students. So you're the only one who knew that link. So that's my way to see if you're really rewatching this, what we call videos that we have. Okay? Are you nervous for the exam? If you don't study, you should be nervous. But if you study, I think you should be able to do okay. But I would suggest go over the reviewer, the materials that was posted there. There's a reason why what we called it has to it was posted there. So the way that we're going to do 8:30, I might place some what we call of you in some place that I want. So don't be surprised if I move you to sit on a certain place. And as the rule, you have to use the restroom before, or the next time you can use this is after you submit the what we call exam paper. And we are in 4MO6, okay? So I think you're not going to lose the second time around. I would suggest go early because for the first, it's the first time that I was hold up on that subway today. And I don't want that to you to happen. That's why I said, oh, what if this happened next week? So our MTA is not really reliable. So the quiz is now open. Do you have any more questions? Yeah, I'm going to talk to you, Angelina, afterwards. Any more? So study. If you have any question and the reviewer is not enough for you to understand how to resolve your question, you can email me, because sometimes when I type it, most likely the students get more confused. That's why I always tell them, maybe we can just meet, okay, for a Zoom or virtual session. We will see if I have the time. But I will try find ways. So give me at least maybe 24 hours to do that. So if none, prepare for the what we call exam. And most likely after next week, in 2 weeks, you will have the third exam. So if none, see you on Saturday in person. So watch out for any what we call email, just in case. So do your quiz now.
Professor, I have a question. Before the last exam, you had post like quizzes that we could do before the exam. Are you gonna do the same thing for this exam? Are you gonna post any quizzes?
No, the quizzes
The
that you
week?
have, I make them available afterward.
Okay. Okay, thank you.
Professor, can we leave now or?
Yeah, you can leave.
Oh, bye. Next week.
Angelina, I already corrected it now. You should be able to see your score.
Professor, I'm taking the quiz, but none of my answers are saving.
What?
You can't hear me?
Yeah.
I can't hear you.
No, I'm on. I'm not
Could you
mute.
type in the chat, please?
Thank you, Professor. Have a good
Okay.
weekend.
What do you need, Tyler?
I don't know what's going on, but my service isn't working right now, so I'm going to email you later.
Okay, so see you next week. Bye-bye.